Okay, so do you guys remember our two brothers who needed help placing a fence and a gate?
Yeah.
Okay, now we're going to help them find where to put their mailboxes.
Oh my God.
So the brother in house A decides he wants to put his mailbox at a location that is 1/3 of the way from his house to house B. Okay, if his house is located at -1, 2, and house B is at 5, 6, like on the picture, where should he put his mailbox?
5, 3.
Well, 1/3 of the way. So to help us solve this problem, we're going to draw some auxiliary lines. Okay, right now we're going to draw in like a right triangle. Okay, so here's my horizontal distance. Here's my vertical distance. So let's start with the horizontal distance. Let's think of it this way. I have to go 1/3 of this whole way, but I can think of the distance as having two parts, a horizontal part and a vertical part. So I'm going to have to go 1/3 of the horizontal distance and also 1/3 of the vertical distance. Does that make sense to everybody? And find where that takes me. Okay? So, can anybody see how we could chop up the horizontal distance into thirds? In chunks of what? I heard it. 2. Do you guys see that my total horizontal distance is 6? Okay. So if I start at house A and my x coordinate for house A is -1, and I don't want to go the whole 6, I just want to go 1/3 of 6. So I'm going to take -1 and I'm going to add 1/3 of 6. Okay with everybody? Where does that take me? This is from my x coordinate. Okay, so 1/3 of 6 is 2. So this part just simplifies to 2. So -1 plus 2 is 1. Okay, that's my x coordinate. Now, I saved the y's for you guys because it's a little trickier. It's not so pretty. But I want you to see if you can figure out how to find the new y coordinate. What are you going to start at? 2. So this will be the y. Okay, we start at 2, and then we have to add what third of what? 1/3 of what? Okay? What do you get? Yeah, 1/3 of 4 is a little bit nasty, right?
One point, like 47.
It's something kind of gross. Okay, can we just call this right now 4/3? Does everybody see that it's 4/3? Okay, so if I chopped up 2, if I have 2 candy bars, and I chop them into thirds, how many pieces of candy bar do I have? 6. So 2 candy bars is equivalent to 6/3, right? Candy bar math, it's cool. So if I have 6/3 and 4/3, what does that give me? Correct. Okay, so this is as an improper fraction. Woo! Okay, and then as a mixed number, what would that be? So how many times does 3 go into 10? 2? No. 3 goes in 3 times. How many left over? How many thirds left over? 1. So 3 with 1/3 left over. This is our mixed number. So our new coordinates, the x value would be 1. And then the y coordinate would be either 10 thirds or 3 1/3. It does not matter to me. Which one do you guys like? Okay. We'll go back and forth and use both. So that's my x, that's my y. How do you like them apples? All right, sweet. That's not too bad. All right, flip.
I like apples.
Okay, this is where reading is very important. For example, 2, we have to find the location of a mailbox for house B. If the brother who lived there wants it 1/3 of the way along the path from house B to house A. So brother A wanted it here, right? And brother B wants it somewhere along there. You guys see that we're talking about 2 different points?
Yeah.
Okay. So let's use our triangle again. Our total horizontal distance is 6. Total vertical distance is 4. Now, if I'm going from B to A, am I going right or left 6? Left. So can I say positive 6 anymore if I'm going left?
No.
Okay, so now it's going to be a negative 6, so we got to watch our signs. Okay, if I'm going from house B to house A, am I going up 4 or down 4?
Oh.
We're going from B to A.
Down.
We're going backwards, right?
Down.
We're going down. Okay. All right, so last time we started at point A. Where are we starting this time?
B.
B. So we're going to use the point B coordinates, which are,
5, 6.
yeah, so here's for X. It's going to be 5 plus whatever. And then for Y, it'll be 6 plus whatever. All right. How far of the total distance are we going? Halfway, 1/4 of the way? 1/3?
Does it matter if you do the equal or the semicolon?
What?
Like you did semicolon for X and then equal.
Oh, shoot. I meant to do semicolons.
Okay.
Sorry.
I was
My bad. All right, so for the X, we're going 1/3 of negative 6. So what's 1/3 of negative 6?
-2.
Okay, so this is 5 plus negative 2, which is 3. Okay, here we go for the Y. 6 plus 1/3 of negative 4. So negative 4/3. So negative 4/3. Okay, this time we've got 6 candy bars. 1, 2, 3, 4, 5, 6. What am I chopping them into? Thirds. Chop, 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 chop. How many pieces of candy bar do I have? It's not 9.
17.
18. Do you see it's 3 times 6? Did everybody see that? Okay. So now I have 18 thirds. So now I can do 18 thirds plus negative 4 thirds. So 18 minus 4 gives me,
Hey, I got a question.
I have answers.
Why don't we just put it in the calculator instead of doing all that?
Oh, that's a really good question because all of the Algebra 2 teachers and the college algebra teachers and the pre-calculus teachers are coming to us and being like, these kids don't know how to do fractions. So
What?
you're going to have to know.
Yeah, I love the calculator.
I mean, you think that now, but
No, I
listen before you argue with me. Okay, when you get to Algebra 2, and college algebra and pre-calculus, you're going to have to add fractions, but it's not just going to be numbers, it's going to have variables in it, and like polynomials. And if you don't know how to do this with real numbers, you're going to be dead in the water, which is why that they're coming to us saying these kids don't know how to do fractions. So I'm trying to help you, right, so that you're not dead in the water because they're going to expect you to know how to do this stuff. Got it? Can you use the calculator to check your work?
Yes.
Yes, please, for the love of God. Right?
Well, then that's just like a waste of my time.
Not if it makes you smarter.
I'm not learning it.
All right. 18 plus negative 4.
14.
Good. Okay, so that whole mess gives us 14 thirds. Okay, how do I do that as a mixed number? How many times does 3 go into 14?
4.
4. How many thirds are left over?
2.
Good. Okay. So my coordinates are 3, 4 and 2 thirds.
Just kidding.
Okay, everybody's brains happy?
Sure. Sure.
No, we don't go.
Okay. Okay, everybody else can think about the stop and jot. What is the relationship?
I will get it.
Please be quiet. What is the relationship between the point 1/3 of the distance from point B to point A and the point 2/3 of the distance from A to B? This is a head scratcher. Awesome. What is the relationship?
Is that like the distance apart?
Okay.
They're both equal distance apart from each other.
No, you're not. Okay, you're not reading. You're just reacting to the picture I drew. Read. Okay. So we've chopped it into thirds. We found the point that was 1/3 from A to B. We found the point that was 1/3 from B to A. Does everybody see we've now got thirds? Okay. What is the relationship between the point 1/3 of the distance from B to A? From B to A is this way. So we're talking about this point. And the point 2/3 of the distance from A to B. 1/3, 2/3.
The point. B
What is the relationship between those 2 points?
from A to B is bigger. I don't know. The first one is half of the distance from A to the other one.
It is the same point. Thank you.
What?
Do you see it's just the same point?
Yeah, it's the same point. I just didn't understand the question.
Oh my god.
Oh, well, I don't complicate that.
Okay.
What the?
So we're just like, sometimes we just need to like think and read. Okay, it's just the same point. So it's the same point. All right, so that can be beneficial because sometimes we might be able to strategically pick a fraction to multiply that simplifies our math, right? It might be easier to multiply by 1/3 instead of 2/3, right? But then we would just change the direction, like change which point we count from. Is that okay? Okay. So all right, I want you to use what you know to locate the point that is halfway between house A and B. What are the coordinates for house A? Negative 1 what?
Negative 1, 2.
Okay, and then 5, 6?
5, 6.
Okay. All right. This is your investigation. So use what you know. You're not writing this down?
No, since we don't have jail here today. Yeah, I'm like super.
Okay, I'm gonna need you to focus. You're great. Okay, what does this say? Use what you know, or locate a point halfway. So what fraction of the distance? So instead of doing 1/3, try 1/2. Okay, what's the distance from negative 1 to 5? Okay, so what's half of 6? What's the distance from 2 to 6? Okay. What's half of that? Okay. So no, that's what you add. So now you have to start at -1 and add 2. Get up here. Okay, help Anthony. He's struggling today.
I don't know. Don't worry.
Well, do I look like I'm having a whole lot of fun right now? Yeah, it's called school, bro.
Oh. These dudes are useful.
Forgot to record the video. Okay. Whoops. All right, we'll go back for that last part. Sorry about that, people at home. Okay. Here's a little proof using the directed line, the partitioning a line segment and turning it into the midpoint formula. Okay, it says x plus 1 plus. Stop it. No, there's like tapping and like shooting around the room. Stop wheeling.
I'm throwing something away.
Okay, not right now. You're interrupting my class. Just wait till we have a break.
Ow.
Okay. Thank you. All right, guys, this is our little formula. For those of you, if it made sense to you the way that we were doing it at the beginning, you may continue to do it that way. That's how I do it in calculus. It's totally valid. This is the formula way. Okay, this is the formula that we use. So I'm going to show you also how to use the formula, okay? All right, ready or not, here we go. Ready or not? Okay, can I please have the tapping stop? Thank you. All right. Okay, so we're first going to assign which is 0.1 and which is 0.2. So if we want to go from A to B, that means that A has to be 0.1 and B has to be 0.2.
Let's do that.
Okay? If I went from B to A, then B would be 0.1, right? Okay. So 3 is going to be X sub 1. 4, Y is going to be, 4 is going to be Y sub 1. My board is messing with me. Hold on, guys. Sorry. Okay, we're ready. Okay, 5 is going to be our X sub 2, and 10 is our Y sub 2. Okay, what is our fraction? What's our fraction? 3/5. So that's what we're going to put in for the fraction part. All right, so here we go. We're going to start with X sub 1, which is 3, plus 3/5. Okay, and then we're going to find X sub 2 minus X sub 1. So what's X sub 2? 5 minus 3. Okay, that gives us our x coordinate. Okay, our y coordinate is we start at 4. And then we add 3/5 times the difference between y sub 2 and y sub 1. So our y sub 2 is 10. Our y sub 1 is 4, so 10 minus 4. Okay, and then close parentheses. Okay, now we just simplify. Okay, what is 5 minus 3? 2. Okay, what is 3/5 of 2? 3 times 2 is 6 over 5. Okay, I want to chop 3 into fifths. So I have 3 candy bars, and I'm chopping them into 5 pieces each. How many pieces of candy bar will I have? 15. So I'll have 15 fifths. 15 fifths. 15 fifths plus 6 fifths gives me what?
21 tenths.
21 fifths. Thank you for being brave. Okay, now we're going to do the y coordinate. Okay, what is 10 minus 4? 6. Okay, 3 times 6 is 18. So this is 18 fifths. Okay, now I've got 4 candy bars. 1, 2, 3, 4. I'm chopping them all into fifths. Whoops. How many pieces of candy bar do I have? 20 fifths of candy bar. Okay, what does that give me for my y coordinate?
38 fifths.
Yeah, geez Louise.
Jeez, Louise.
That's a lot of fifths.
It's a lot of fifths.
Really?
We can make those in the proper fraction, bro.
No, I'm not. I don't have it in me, guys. Like Anthony said, we're tired. It's break. It's after
I
break.
got it in.
But you still gotta do work.
Yeah,
That's exactly.
Can we if we want to? Though?
you can.
Okay.
It's good brain exercise. How many times does 5 go into 38?
7.
7 with how many left over?
3.
So 7 and 3/5. Good.
It'd be 4 and 1/5 and 7 and 3/5.
You are correct. All right. Okay, suppose that segment AB has endpoints at A, which is -1, 2, and B at 7, 8. Point P is located at 13 thirds and 6. Whew. What fraction of the distance from A to B is point P located from point A? So we're going to solve for the fraction. You guys ready? Okay. So we can use our little formula. So for the x coordinate, it's going to be x equals our x. Oh, sorry. Hold on, I'm having a brain fart.
Hey, want these? Anthony. You want some Anthony guac?
Oh, I did treat you like a dog.
I did not.
Okay. Whoa. All right, so, hey. All right, so we're going to start with our new x coordinate. Our new x coordinate is 13 thirds. Okay, so that is going to be the x that we started with, x sub 1, which is what? What's our x sub 1?
What is our x sub 1?
Yeah, what's our x sub 1?
13.
No, look at it.
Negative 1.
Negative 1. Okay, plus, we don't know the fraction. Okay, so the fraction, what do you want to call the fraction? F?
Yes,
Call it 1 half.
Can we call the fraction F? Okay,
yeah.
plus F. Please be quiet.
Okay.
Okay, times our x sub 2. Here's x sub 1, x sub 2. Our x sub 2 minus our x sub 1. So 7 minus our negative 1.
That would be plus.
Really?
Yeah. Okay, I was just letting her know. Okay.
No problem.
Okay.
Okay, so this is, let's label. This is our x sub 1. This is our fraction we don't know. This is our x sub 2. This is our x sub 1. Okay. So our 7 minus negative 1 turns into 8. So over here I've got f times 8. Okay, how do I undo subtracting 1?
Oh, you what?
You add it.
I add it. How many thirds is 1?
What?
Look, I've got,
3.
yeah, so I'm getting rid of I'm doing
Oh.
3 over 3 plus 13 thirds, right?
Yeah.
Equals the fraction times 8. All right, so 16 thirds. Okay, how do we undo multiplying by 8?
Divide it.
Divide by 8 on both sides. Divide by 8. Divide by 8. So, how many 8s are there in 16? 2. So 16 is a 2 times an 8, so the 8s are going to cancel. Do you see that I just get to keep my 2 thirds? Okay, cool. So my fraction is 2 thirds. All right, let's double check it by doing the y coordinates. The y coordinates are nicer. All right, we're going to practice. So I start with my 13 thirds. No, sorry, start with 6. Equals my y sub 1, which is 2, plus my fraction times my y sub 2, which is 8, minus 2. Okay, this is my y sub 1, y sub 2, y sub 1. Everybody see where that stuff came from? Okay, 8 minus 2 is? 6. Subtract away the 2 from both sides, I get 4 equals f times 6. How do I undo multiplying by 6?
Divide.
Divide both sides by 6. We probably should have started with the y coordinate, huh? This one's less gnarly. What is 4 over 6 reduce to? Yeah, 2 thirds.
Yeah.
Okay, do you guys want to see the way I would have done it? If it saves you all that work, do you want to see the way I would do it?
Yes.
Okay. So I'm looking, the way I would do it is only helpful if like one of your set, do you see that all the y's are pretty?
Yeah.
Okay, do you see that after all this work, we got the same fraction using both? Okay, so as long as I'm careful and I do it right, do I really just need one? Right? So you pick the cute one, the nice one with the pretty numbers. So what is my total distance from 2 to 8? 6. What is my distance from 2 to 6?
4.
What is 4 over 6 reduced to? Okay, that's why I was dying when I was trying to come up with the formula, because all I could see was the easy way. Right?
Yep.
Okay, but don't you feel smarter?
Yep.
Okay. All right. What fraction of the distance from B to A is point B located, oh my God, P located from point B? All right, let's draw a picture, because I've already got myself confused. Okay, so my picture is not going to be to scale. Okay, P is what fraction of the distance from our previous problem from A to B? 2 what?
2/3.
Okay, so P is here. It's 2/3. Does everybody see what's happening?
Yeah.
Okay. So it's saying what fraction of the distance from B to A? So from A to B, it was 2/3. But if I go the other way and I go from B to A, what is it?
1/3.
1/3. So that was really confusing until we had a picture. So one of the most powerful and sophisticated tools you have in your mathematical toolkit is just to draw a picture. All right, point P splits A and B into two smaller segments, AP and PB. What is the ratio of the measure or the length of AP and the length of PB? Okay, the order matters. So if I say of AP to PB, then I have to put them in the right order. So which one goes first? The measure of AP. So that one is 2/3. Okay. And then the measure of PB? 1/3. Okay, but we're not done because we got to simplify this. You guys are going to love this. Okay, you might remember that an alternate way to write a ratio is as a fraction. So this would be 2/3 divided by 1/3. The reason this looks gross is because of the 3's in the denominator, right? Mm-hmm. So it's legal to multiply the top and denominator by the same number. So I'm going to do times 3 times 3. Because if I multiply by 3 over 3, isn't that just a big fancy 1?
Yep.
Okay, so I'm just timesing by 1, which doesn't change the value. I'm just changing the way it looks. So 2/3 times 3 is? 6, and then divide by 3.
2.
Don't the
It is 2.
3's cancel and left with 2? This is probably more work with fractions than you've done in many years, so I'm not surprised that you're rusty, but this is why we're doing it, right? It's 1. Okay, doesn't that make sense that it's twice as long?
Yep.
Okay, could you now see that just by looking at it? Okay, awesome. Oh, is there more? Oh, shoot. All right, we're going to do that one tomorrow, maybe as a warm-up.